Today we're looking at design of experiments. Particularly, we'll be looking at completely randomized design experiment. Let's head on to Minitab and then see how we can handle a data set that is given to us. Now, if you are following from the previous videos, you would understand by now how to load in our data set. So we go to the file or we click on this open, then we look for the data set that we want to open. And we used crop yield last time. We're going to use the same thing. It's a CSV file, and we want to open that up and then see what's in it. So this is the layout. So I just leave the default, every default as it is, and say okay as before. Then we can expand this a little to see a little bit of the data set in there. So again, we have three columns here. Okay, so these three columns that we have, what do we do? Now, in most of the softwares, to perform analysis of variance, it is expected that the irrigation methods that you see at the top as variable names should have been values in one column, and the yield that you're seeing will also be in another column. So this would have been two columns. Yes, we can do that here, and we can also allow them be like they are for us to perform an analysis of variance just as it is now. So I'm going to do both to show you how you can do that in Minitab. So Minitab is kind of flexible and provides us that convenience to choose between how your data is structured in terms of analysis of variance. So let's head on to statistics. Then we go into ANOVA. Here, CRD and one way is more like similar, and so I can just go with one way analysis of variance without any problem. So right now I have here at the inside this box, I have two of the options here. One says response data are in one column for all factor levels. So this, if I pick this one, it will mean that I have to restructure my data set so that the irrigation methods will be in one column, then my yield data will also be in one column. That is not how it is right now. We will come to that one later. So I'm going to take the second one that says that my response data are in a separate column for each factor level. So these are the factor levels you are seeing, and they are all sitting on different columns. That is what the second option is saying, and so I will pick that one. Now my variables are not showing. Why? Because I have not clicked inside where I want to put them. So this is my response. Once I click inside here, then you can see that they all come through the variables window here. So what I'm going to do here is to select all of them. In our previous videos, I showed you how to get them inside. You can just pick them one at a time. If you have many variables and you are not going to put all of them, you will have to choose those you want to. And how do we do that? One, we can, if you're picking all of them, like in this case, I select I select the first one, then press my shift key and select the last one. That is if I want all the variables there. If I don't want all the variables, I hold my control key and then I select those I want to select. It doesn't matter where they are in the variable list. So you can hold your control key and do the selection, all those that you want to. And after you are done selecting, then you come to the bottom here and say select. Click on select here. It will send them over to the response variables box. So not all of them are inside, but I want them all inside. So I'm doing it again. Oh, okay. All right, so they are all inside now. Now let's go to the options and select our options. What options are there for us in terms of input is not valid? Okay, there's a duplicate there. I think I added this two times. Okay, so go back there. Then again, let me pull this aside this is more like the assumptions, equal variance. So we're assuming that the three, all of them, they have equal variance, and so I would just leave it there. Then I'll leave the default here as confidence 95%. That means that we have 5% error. Your alpha value is 0.05, and the hypothesis is a two-way. So we are looking at the means are equal, or alternatively the means are not equal. So we'll leave it as the two-way confidence interval here and just say okay. Comparison, if there are differences, do we need to do some comparisons? Yes, we would want to select that. If any of the means are different, give us comparison. So we will pick the 2K for now. Now the Janet, if I have a control, I probably would want to choose that, because I would want to choose which one is control, and I'll use the control to compare with the treatments and see whether or not they are different or the same. So as for example, I will just leave it as the 2K here, and these are other options that you can also go ahead to pick. I don't want this plot, but I want this grouping information, and that is where it uses the letters A, B, C, D to indicate which of the means are the same and which ones are not the same. So I'll leave the rest as is and say okay. Graphs. What graphs do we need? Interval plots, individual plots. So again, these plots, you would have done them in your descriptive statistics, but the interval plot, I'll just leave that one for now for us to see. Okay, and then leave just this one here as is. Results, that is the final stage. What is the results that we want to see? We want to see the method that is used, the method information, the factor information before we come to our actual results here: analysis of variance table, the model summary, and the means table. So you can also have this expanded table that will give you more results than in the sample. So once this will contain the sample, I will just pick that one for us to see everything that is there. Do you want to store the information, predictions, your results? Do you want to store anything? If you want to store anything, you take this one and then you indicate what you want to store, the fitted values or the residual values. But I don't want to store any of that, so I'll just leave it as is and then go ahead to say okay and wait for my results to pop up. So again, we have these results here. The method, it's here. Null hypothesis says that all the means are equal, and the alternative is saying that not all means are equal. So at least one of them is not equal to the rest of them. So that is our null hypothesis. Then our factor information. What is the factor? How many levels is our factor? 3 levels, and what are the values? Drip, sprinkler, and the furrow irrigation method. So we come to the ANOVA table, and everything here from the source to the p-value. Now my interest will only just be in a p-value for now, okay, to determine whether or not the factors that we have, the three different methods, irrigation methods, is there any significant difference in the means? And this p-value says yes. Now if I have this, if I have say if this p-value is less than the alpha value selected, we have alpha here that is 0.05. If this value here is less than 0.05, so we want to say there is significance between the means. If it is not, then there is no significant differences. Okay, so right now there is significant differences, and so it is good that we check on the comparison to see which of them is different from which one, and which one is higher or which one is lower. Now in terms of the model summary, let me stop at this R square here to say about 30% of the variability in crop yield is explained by the different methods of irrigation that we employed here. And so it tells us that there is yet other factors that also contribute to the variability, or that can explain, um, influence the variability, the yields of the crops that we did not consider, but only considered the irrigation methods that only explained about 30% of the variability in our response variable. In terms of the means table, we'll just jump here and come back to that later, because here in the next grouping table, information using the 2K method, we would be talking about the same set of means too and trying to compare them. Visually, there is difference 29, 28, 26, but then is this visual difference wide enough or big enough to say there is a difference? And that is where these groupings comes in. So the test information comes back as that all three irrigation methods are different from each other. So dripping is different from sprinkler, dripping is different from furrow, sprinkler is different from furrow. So that is why all the letters are different. If dripping and the sprinkler were the same, you will have AA here, but then the furrow irrigation would have had a different letter. Okay, but as it is, all of them, they have different letters, indicating that the mean for each of them is different from the rest of them. No two of them are the same. And now the only graph that we selected will simply just show you visually where the mean yield is in terms of the different methods. So drip irrigation is at the top here, around 29, closer to 3,000, and then sprinkler follows, furrow follows. So definitely this will look more appealing and more clearer than looking at numbers and letters. And so we can just look at this one and tell that, okay, this one gives much yield as compared to the rest of the two. So basically this is will be our CRD, and we would have done with one way ANOVA here. Now the other one I said was going to show you is to actually transform this data to the two columns. And so we would want to go into data and then look for stack here. I want to stack the columns. Okay, so these are already selected. I would unselect them. So what do we want to do? We want to put all these three inside here. So I select them and they go inside. And then do we want to create new one? I want to put them here so that we can just see them as they are. And so I say column of current worksheets. Okay, so let me just give them names. So column of current worksheets. So test name, just leave it at test name. Store in subscript, this is optional, but I will just give it a name, practice, and then use variable names in subscript column. So what does this mean? If I leave this as is, well, I'm not going to see the sprinkler and furrows there. I'm just going to see 1, 2, 3 representing them that I can recode later on. But why do I have to go through the stress when I can just allow it to go inside? Okay, so this is what I'm just going to pick this, and everything is filled up, and I say okay. So you can see it comes here. Test name, that is my yields, and then the practice, that is my drip irrigation methods. And you see these ones, the variable names have become values in a name that I have given to it, and then the test name is the yield that I have here. So if I scroll down, you would see at this level it's 50 rows. So this is where the drip ends, and I'll scroll another 50, and that is where the sprinkler ends, another 50, that is where the furrow ends. And so it has transformed the data into just two columns, where the irrigation methods would take one column and your yield will take another column. So we can go back to our ANOVA to do the same analysis, but this time we are saying this is not what we want to pick. So we are going for the first one that says my response variable is in 1, and that is my test name. I put it there. Then my factor is the practice here. I put it in the factor column. I can specify the options as before. But now I'm just going to leave it as is and just say, okay, we saw how we can go inside and make the choices that we want. And so we can see here the results are not showing differently from each other. So this is the same as we saw, and then our R value is the same thing. So nothing has changed, just the location. So here sprinkler was second, I think the last one. Let's see. Yes, drip sprinkler furrow. This time furrow is in the middle. That is why you are seeing that curve there. But in the first graph, sprinkler was in the middle, so you see a downward slope. So basically nothing has changed, it's just the layout of the data set and we getting the same results. So I hope this helps. Any questions, again, drop them and let's see how best we can answer them. Thank you.